Good morning, everyone. In this video, we are going to discuss in detail about the carburetor. Carburetor is a device which works on Bernoulli's principle and is used in petrol engine to control the amount of atomized fuel and air in the air-fuel mixture to be supplied to engine combustion chamber. Carburetor is provided with the trough in which the air stream flows. The velocity of air is to be in the trough as compared to velocity at entrance, and this high velocity reduces the pressure inside the throat, which makes the fuel to enter into the throat due to pressure difference and gets mixed with the air stream. Under all conditions, the engine carburetor must perform the following functions. So it should regulate the airflow in the engine. It should supply the required amount of fuel to maintain the level of fuel air mixture. So it should prepare the exact fuel and the air mixture. The following are the components of the carburetor: floating chamber and float, venturi, nozzle, throttle valve, fuel jet, choke. So first let's see about the float chamber and float. Special purpose lightweight brass metal is used in the float chamber to maintain the constant level fuel in the float chamber. The float is attached to the stopper like mechanism to allow and restrict the entry of fuel in the chamber as it moves down and up. The metallic float have tendency to get damaged and leak from the joints. So to avoid this, plastic or rubber material is used for manufacturing float. The level of fuel in the float chamber is maintained low than the nozzle outlet. Venturi. The fuel from the nozzle flows into the venturi, which is simply a restriction in the air passage. It is the area where this passage area in the direction of the airflow is minimum. As the passage for area decreases, it increases the air velocity and hence decreases the air pressure. Due to this depression in the pressure, the fuel comes out from the nozzle and gets mixed with the air and converted into the fuel chambers vapors. Then this air fuel mixture is entered into the engine cylinder through inlet manifold. The quantity of the fuel entering the cylinder depends upon the jet size, float level, and venture vacuum. Nozzle. It is used in the venturi to discharge the fuel and get mixed with the airstream. The nozzle outlet is placed above the level fuel in the float chamber to avoid spilling of fuel from the nozzle when vehicle is turning on slope and highly chambered roads. Throttle valves. It is used to control the quantity of flow of air fuel mixture. It is attached to the accelerator pedal through lever mechanism. Butterfly or cylinder valve are used, but butterfly type is most common used valve for controlling the air fuel mixture. Butterfly type is simply a disc type mechanism hinged at the center. Although it is easy use and operate, but it restricts the flow even when it is fully opened. No suction is applied to the nozzle when the throat valve is fully closed. Fuel jet. The flow of fuel from the float chamber to the vent through the nozzle is metered by fuel jet. It regulates the fuel supply. Fuel jet are made of some special brass metal and should have anti-corrosive function. The engine idle speed and corresponding idling mixture is adjusted with the help of stop screw provided on the top of the jet. Idle speed of the engine is adjusted by top stop screw at the top at the point where engine runs smoothly on the slowest speed at no load. Main jet adjustments are done after the engine is warmed up and put on load. When engine turns at full throttle, the main jet is turned until the full power is regained and engine runs smoothly. The jet screw is rotated further to avoid engine stalling due to over variation. Next is choke. It is a butterfly valve operated by hand lever or something automatic to restrict the airflow and hence increase the proportion fuel in air fuel mixture. The choke is generally applied for initial starting purpose. The choke is to be operated immediately when the engine gets started, otherwise the flooded fuel would result into engine stall. Carburetor can be of following three types on the basis of direction of air fuel mixture is supplied: up route, down route, horizontal. Out of above mentioned type of carburetor, down route is the most commonly used type due to following advantages: fuel flow due to gravity, which helps the engine under load to run smoothly at lower speed. Volumetric efficiency can be enhanced and it is easy to assess. Fuel properties. Engine needs to run on fuel of high quality to produce maximum work output. Several fuel properties have been identified and defined as follows: heat valve or calorific value, specific gravity, volatility, flash point, fire point, pour point, viscosity, octane number, cetane number, carbon residue, sulfur content, gum content. Heat value or caloric value. It is the indicative of heat energy being produced by the fuel when it is burned inside the cylinder or combustion chamber of the engine. It is expressed in joule per kg of fuel and is measured in the device which is known as calorimeter. The impurities in the fuel leads to decrease in its heat value. Specific gravity. It is expressed as the ratio of intensity of fuel to the density of water. The specific gravity affects the fuel atomization in the nozzle and spray penetration or injection in the engine cylinder or combustion chamber. Fuel which are relatively heavier have usually greater heat value. The specific gravity is measured by the hydrometer. Volatility. It is the property of fuel to get converted into vapor or burned at specific temperature. The volatility is measured by means of distillation. In diesel fuel, volatility is indicated by 90% distillation temperature. Low volatility in fuel leads to increase in carbon deposit, smoke content, and also wear of engine components. Flash point. It is the temperature at which the fuel must be heated to get flammable vapors and is driven off to ignite when brought into contact with the flames. Fire point. It is the higher temperature at which the vapor will continue to burn after being ignited. Generally, the fire point is 10 degree to 21 degrees Celsius higher than the flash point, and it is the indicator of fire hazard. The lower the flash point, the greater is the fire hazard. In general, the flash point should be higher enough to avoid producing flammable vapors. Pour point. It is the temperature at which the fuel became insoluble to prevent flow under specific condition. In cold weather condition, this became very important parameter as wax crystals start forming even when temperature is slightly over the pour point. A high pour point implies that in cold weather the fuel will not flow easily through the filter and fuel system, and also the automation or power spray characteristics are affected. Engine detonation. It is an engine refers to inappropriate combustion of fuel in the combustion chamber or cylinder of the engine. Either the compression of air fuel mixture is burnt in the cylinder with the help of spark, or the air alone is compressed during the compression stop and fuel is injected and burned due to compression. To get maximum power from the engine, it is required that proper of air fuel mixture or fuel is supplied to the engine and ignited at proper time. Sometimes where pre-ignition of fuel can happen in the engine, it also observes that whole of the fuel or air fuel mixture is not burnt at once. Due to this, a pressure wave is set up in the combustion chamber which travels to and fro and hits the cylinder wall. This disturbance in the cylinder forces the valve at the frequency of gases, which produces a very peculiar sound which is known as engine detonation or knocking. Engine detonation can be illustrated as it can also occur due to sudden and instantaneous ignition of an unburnt charge when the temperature and pressure is so high and sufficient to ignite the fuel or air fuel mixture. The factors affecting engine detonation can be classified as engine factor, air fuel, and air fuel mixture factor. Engine factor. There are engine characteristics which can affect engine detonation includes compression ratio. Engine detonation increases with increase in compression ratio as it increases the gas temperature and pressure, thus lowering the reaction time for charge to get ignited. Every engine is designed for a particular maximum compression ratio, and any compression ratio beyond this causes engine detonation. Engine size. Engine detonation increases with increase in cylinder size, that is bore. Spark advance. Retarded spark helps in lowering the detonation, whereas over advance in spark leads to more detonation as pressure gets higher than the normal maximum pressure. Design of combustion chamber. The design which produces more turbulence in the combustion chamber. It helps in rapid combustion of charge and hence decreases the chance to knock the detonation. Defective cooling system. If engine cooling system is not working properly due to fault in engine thermostat, water pump, etc., it also increases the engine detonation. Engine speed. At high engine speed, which may also lead to fall in volumetric efficiency, the engine detonation is decreased. Valve timing. As the valve timing increases the volumetric efficiency, which increases the air fuel mixture intake and increases the cylinder pressure, the tendency to engine detonation is also increased. Effect of detonation. The main effect of detonation are inefficient combustion, loose power, local overheating, mechanical engine failure. Prevention of detonation. The different methods used for the prevention of detonation are anti-knocking agents, cooling of the charge, reducing the time factor. Thank you.